Welcome to a new test and teardown video. This time it's another DC power supply. This one is from Delta Elektronika in Holland. It's called DO30-3. So I think that is due to the 30 volts, 3 amps. At least that's what we see on the meters. It is very, very heavy. 11.7 kilos. It's quite old as well, and I think it doesn't work. We got nice multi-turns. Really good switch, and let's have a look at the back. So this is the power entry connector, and I think this reveals the age a little bit. I think all the heat sinks and stuff that will be inside. Yeah. Got some cooling holes here and some feet, and the feet there aren't really that high. Damn, this is heavy duty. So I think I now know why this one is so heavy. Look at the size. But so is this pre-regulator or something like that? Where's all the transistors? I mean, we got 3 amps. Okay, that's it. We got some transistors down there. Ah, now I'm getting it. Look at that. This one is an inductor. So it's actually a switch mode. And they're doing these kind of... Yes, I think that is what we have here. And we've got some more transistors down there. So it's probably pre-regulated. But it's really, really dirty, so I have to go outside and give this a lot of compressed air. It also smells a little bit nasty, so I will be back. So I am right about the pre-regulation. It is an SCR regulated power supply, and that is of course why we got this huge inductor. I don't know exactly why we have this transformer that big, but anyway, this will be the control board for everything. And as you can see, it is a very, very old design, and I've been googling around like crazy, and all I find is a very simplified schematic that shows just the main SCR regulator and the inductor and the transformer, and a little block diagram that explains how it's triggering the SCRs, and not a lot more really. So I also found a tiny little bit of information about its age. So I think this is from 1966 to 1972. I mean, that could be right. This is probably, I don't know exactly what is going on down there, but that was a fuse and a capacitor. Okay, there's a label behind that. Look at that. I want to unscrew that one and let's have a little look. It also looked like this heatsink in here is isolated from the chassis. So that is electrically isolated. This can't be good for thermal. We got the 2 SCRs right there, and down there we got some diodes, and that is the rectifier and We also got 2 extra transistors right there, so maybe there's a linear after regulator or something. This is not explained in the simplified schematic I got. And there's also a tiny little regulator, as you see down there. This is of course the main capacitor for the first stage. I don't know if you can see this, but the transformer is just huge. I didn't find any burned components, so I think, I mean, is that a little leak? Oh yeah, oi oi oi, look at that. Let's take this capacitor out and have a look at that one. I should probably do that. See, this one is corroded. This can't be just dirt. Let's look from the inside. Here you see, yeah, that is quite clear, right? That is corrosion or leakage that's just pouring down. That one, it's just way too heavy. Whew. I also find the main transformer. We got some windings here and they are at the moment coupled, as you see here, for 110 and 110, so that is 220. But we also got 10 and 10, so I can upgrade this or connect it correctly for the mains voltage we got at the moment. So I should probably do that before powering it up. There isn't anything to show here at the bottom, but we got the sockets for 2 of the circuit boards, and all the wires, they put them up on top and not here on the bottom. They could have hidden the wires underneath here or something like that, right? But they wanted the wires to be here, so this is a little bit funny, isn't it? I would probably have, connect this stuff like that and make it nice and neat, but that's just probably only me. So let's look a little bit behind this cover here. All the access to sense and even remote. Look what we got. External this and external that. And they, at the moment I can see here, voltage and current adjust internal. So if you connect all this exactly like that, just really brilliant idea. And I also love that we have the documentation right here. Still haven't figured out what that component is doing. It is one of their own, I think it's just some potted component or something like that, right? And it looks like we got some leakage under it. I should probably try and desolder it. And it looks like somebody else desoldered it. A thick layer of coating. I don't think I'm happy about that, so I should clean the contacts. And here on the top, this spacer, that was looking like that, really burned. So that resistor here, I think, goes absolutely warm. We can see the kilo ohms. So why is this so warm? I should probably measure this. I really don't have the schematic, so it's driving me a little bit nuts. Kind of like the way the transistors here, they're coupled together in pairs for thermal stability. Maybe this is a zener reference or something like that. And then there's another little circuit board. I should probably try and get this out as well. This will also let me clean it up a little bit better. Oh, now we can see the power diode in there. And probably also the SCRs. I bet that will be 2 and 3668. So I took that mysterious capacitor out, And when I'm looking at it now, it's not looking that bad or anything like that. See, it's from West Germany. And I mean, this is probably from the 70s or something like that. And it measures today about 700 micro at 0.2 ohms at 100 hertz. And of course, I'm testing this at 100 hertz because this unit, of course, runs at 100 hertz. So let's try and see how a modern capacitor, this is a switch mode grade modern capacitor, how that one measures. Well, this one is specified 500, but it's plus, no, this is the temperature, this is not the tolerance. Okay. I was hoping to be able to see anything, but I don't. But anyway, this one is so I go for a 680. So I'll go in that range as well, right? And see, it's a little bit less in capacitance, but the internal resistance is lower. And it probably also handled ripple better. So I'll try and stick this one in. So I also took the next board out. And see, there's another little rectifier and another little transistor. So this is probably the firing system for the SCRs. And definitely those two up here, the 2N3668, that will be SCRs, 100 to 200 volts, 16 amp each. But we got two more, I think, down there. So I want to see what that is. So I think I need to remove that circuit board as well. And I think it's really funny. We have another rectifier bridge there. I mean, all those rectifiers, what is going on? I would really love to have a schematic. If anybody got a schematic for this one, please see what I figured out. Just desoldered that one. It's not super service friendly, but I can actually bend this board out enough to show you we got two N3055s. So there's a linear after regulator here as well. How about that? I did not see that one coming. So that is probably some of this, but it's only for 3 amps. Aha! So are they in series or are they in parallel? Or what is going on down there? I don't know. But I don't find any little pre-driver for this. And how is this? Oh, okay. So this is how it's supposed to be cooled. It's mounted at the bottom, and that is it. Well, that is the cool thing about having a pre-regulated SCR voltage. Now you don't drop any voltage and you will have a very high efficiency. I hope to demonstrate that if this thing works. But so is this just the little pre-driver for my output or something like that? Okay, we also got some sort of sizes on this board. I mean, those transistors right here, they should be able to drive. See, 2N3053. Where is the current sense resistor, by the way? I haven't found that one yet. So now I'm going to assemble this thing and try and see. Yeah, let's try my luck. But there's one more thing I really want you to see. So there's a power resistor right here. I mean, look at that. It's electrically isolated from the heat sink, but it's also thermally isolated from the heat sink. But it's already an isolated resistor. What is the idea? So it can go, I don't know, what is the point? The weirdest of weird design ideas, right? So I am in the reassembly process here. And now I realize why we got those little plastic isolators. I mean, those little plastic washers here. Look at that. Let's see if I can get the camera down there. Here you go. Nah, it's not gonna focus. But I think you can probably see what I mean. Oh, that is so dumb. This is what happens when you design stuff without CAD and without proper checking, you know, what is going on here. Oh, that is so funny. Oh, by the way, I found a date code on this main capacitor. It's probably impossible to video this, but it says 1969. Come on, where is it? Yes, here, see? 69. Come on, man. Yes. What is it with this paint job? It's like really, really funny and shiny, and it looks like home spray painted. So what I did is, I of course removed one of the little rubber feet. So that will be the original color for this type. So it's a much, much more beautiful paint job. And also a much more beautiful color, by the way. Ah, typical. Why isn't somebody want to screw stuff up? It was beautiful. Let's try and do the first power up together. Just a little bit of that. I'll turn it off, and then I'll try and give it just a little bit of AC mains if there's any shorted. Just give it like 30 volts of AC, and then we'll see if there's any. Oh, it's using a half a watt. So that is probably fine. I'll now try and slowly crank up the mains supply. So that is 100 volts, 140, 150, 180, 226. But what have we got? It is responding to my voltage. Let's give it 10 on the meter. Oh, what? That's really nice. Let's go. Oh, I love the 10 turns here. It works really, really good. So I try and look. And that is also very close. Let's see if it goes all the way to. Oh, there's a little margin. I love it when it goes like. Okay, so that is nice. Those meters are also Cifra meters, as you can see here from the big S logo, and they're just known to be super, super good quality. So that's probably why it works that well. So let's try and load this thing and see what's happening. So what did I do? Oh, it even goes all the way to 0. I also love when they go to 0 like that. So now we have okay, let's give it one more turn. So current is 0.2 on my load, and that is 0.2. And okay, I should probably crank up the load slowly, see what happens. See, it goes into current regulation, or yeah, so now it is in constant current, and I can of course, everything here goes nice and smooth. So what I really want to do is let's crank down the voltage to 20, and now let's look carefully on the voltmeter when I go in. No nasty. Okay, I feel like I want to give it a little bit more. I think the meter is a little bit on the low side. now that is 1 amp. See, it's reading a little bit too low. So that I will probably see if I can figure out where's the trimmer for the current. I mean, and then see again, all this. Oh, see, there's a little, whoa, a little bit of overshoot. So, hey, we can try something funny. So at the moment I'm using 1 amp and 20 volts. So that is quite easy to understand. That is 20 watts of output. So how much is this using from mains? It's using 42 watts. So that is an efficiency of about half, 50%, right? So what if we crank up the voltage a little bit? So that is 30 volts, 1 amp, that is 30 watts, okay? Now the power consumption is 53 watts on the mains. So it's actually a little bit higher efficiency. What we can do is try and crank up the load even more. So that is 2 amps. Oh, I said 2 amps. So that is 60 watts of output. And we're now using 94 watts on the input and 3 amps. And so 3 amps is 90 watts of output, and my input power is 132 watts. So that is a 68% efficiency, and I mean that is pretty nice for a power supply from the 1969. I really want to measure some ripple, and yeah, let's see about that. There are just so many things I want to try and play with this thing. I'm super happy it works. It's idle power. Okay, that is how it is. So idle power is very much affected by output voltage. So it's using 12 watts of idle. I better write this down. Okay, so 30 volts is it's 12 watts of idle. So if I put it down to 0 volts, now it's using 8 watts. Okay, so there is a resistor on the output that will discharge all the capacitors. So let's measure the voltage on the SCR pre-regulator, that big capacitor I shown earlier. Here we go. That is, of course, the pre-regulator capacitor. And so that is the voltage here. And if I crank down the output voltage to 0, so we have 12 volts on that capacitor. So that is also 12 volt over our series regulator, the linear stage. And that is, of course, because we also got some ripple here, we need to be able to contain that ripple within the linear regulation. So it's probably the same. Yeah, you see, it's still 12 volts. So there is some system here that measures the output voltage and just add 12 volts on that capacitor. So that is just what it's doing, more or less. That's interesting. Let's look a little bit on the ripple. So I just connected an oscilloscope. And let's just look a little bit on that picture here. So what have we done? We're in AC mode, and 5 millivolts per division. Oh, this is 1 amp load. Let me crank up the. We can only do 3 amps this thing, so that is 2, and that is 3 amps, and this is at 10 volt output voltage. So let's just crank up the juices here. So this is 30 volts and 3 amps, full 90 watts of output, and that is all we see. What I really want to show as well, so this is super silent and all that. Let's try and see the step response. So this is interesting. So to show the step response, I need to dial down the voltage. Let's just go 2 volts per division, and let's have a trigger that is actually up here, right? And then we go into normal mode. So, and if I turn off the load, there's nothing to see. I would expect. Why don't we see anything? Because see, when I turn on and off the load, what? Really? So I would expect. What? All we see is. Are you kidding me? See that? Tiny little 100 millivolt drop is from 0 to full load. And then here we go. Let's do it again. So when so there's just there's almost this is really not a lot. So this is 100 millivolt when I give it loads. Okay, so let's see the load drop. So now we're going to the trigger, and then we should set, oh, it is actually in a rising edge. So that means just like that. You would expect it to go positive, wouldn't you? So now I turn off my load, exactly, and then it goes up, and then it takes a little bit of time for the regulation to work again. I mean, that is fantastic. I would have expected, I mean, several volts and all sorts of annoying things, but it's just some transistors and stuff from 1969, and it's still absolutely amazingly good. Fantastic. I am so happy about it. I mean, the only thing I can complain about, that is this lamp that is a little bit, see how dim it is? I mean, I should probably make it a little bit brighter, but that is all I can find to complain about. So yeah, I think I'll just end this video with a super happy face and say thanks a lot for watching. I hope to see you soon again. Bye bye.